Hello everybody, welcome to Maths Easy. Today we are going to do another question on Kirchhoff laws. Now we've done two videos on it. This is the third one. And if you've already listened to the first two videos, please make sure you pause the video, this one, and try this question because it's quite similar to the previous two questions and hopefully you can do it. But if you need any help, obviously, press play and check it against my answers, right? Now, as usual, the first thing we do is we need to mark the current. So let's mark the current starting from here. Capital I, capital I, lowercase I, and this is I take away I. And that same current comes from here. Lowercase I come here. These two come together to make capital I once again. All done. Now we need to label it. So let's call this point A, B, C, D, E, and F. Now I can write my Kirchhoff's second law equations for this loop, or the big one. So you can really choose anything. So I'm just going to start with the one on the left. So let's do it for A, B, E, F, A. This way. So sigma EMF is equal to sigma PD. Sum of EMFs is equal to sum of PD. Now let's find the EMFs. So let's do a walk from starting from A, looking for EMFs, no EMFs, no EMFs. There's only one, and that's pushing the way I'm going. So that's basically 5 volts. So let's put 5 on this side. Now we need to do the same walk and find our PDs. So let's start from here. Oh, I got one of them here, which is 2I. That's the first PD. Then I can go like that, and there is 6 lowercase I, and that's it. So let's write this one. 2 capital I plus 6 lowercase I. That's my first equation. Now let's do the same thing for another loop. So let's specify the loop. Maybe we'll do the one on the right hand side, and let's write it from B, C, D, E, B. Right, I'm going to do my first walk to find out any EMFs. So no EMFs here. Oh, there is one. But now look, I'm going in a clockwise direction and this is pushing in the opposite direction. So that's -2. That's my EMF. And there is no other EMF in this loop. Right, let's do another walk to find the PD. So starting from B, I have 4I minus I. Nothing. Oh, now this way, I'm now going against the current. Therefore, I have 6I, but that has to be negative. Why? Because I'm moving this way from E to B, but actually current is going the other way, the way I marked it. So let's write this down. 4I minus I minus 6I. Let's simplify this further. -2 is equal to 4 capital I, 4 times negative lowercase I, that's negative 10 lowercase I, 2. So, like in our previous questions, all we need to do is solve these two simultaneously. I can just see that I got 2I here and I've got 4I here, and the whole equation is divisible by 2. So let's do that to make it easier. -1 is equal to 2I take away 5 lowercase I. Now all I need to do is make 2i the subject from each one and just equate them. So here's the calculation. 2i is equal to 5 take away 6i from the first one. From the second one, 2i is equal to, this negative 5 becomes positive, 5i take away 1. Now the left hand sides are the same, so I can just equate the right hand side. 5i minus 1 equals 5 take away 6i. The 6i comes to this side, which is 11i equals 5 add 1 is 6, and I is equal to 0.54. Now the question is, what is the current flowing through the 6 ohm resistance? The answer is 0.54 amps.